So we were talking about perfect squares. So give me an example, please, of a perfect square. Is it? X plus 2 squared. Okay. So we've got x plus 2 squared, and what would the... So that's the factorised form. What would the expanded form be?
X squared plus 2x plus 2.
4x plus 4. X plus 8 squared would expand to?
X squared plus 16 plus 60x
plus 64. Okay. Finish this one off for me. X squared plus 10x. I tell you, it is a perfect square, Nick. Plus 25, and the brackets, the factorised form would be x plus 5 squared. Okay, one more before we move on. So finish this one. X squared minus 14x. Pardon? Plus 49. And in the brackets, factorised form?
X minus 7.
X minus 7 squared. Good. Okay. So, perfect squares. How did we say we recognised perfect square? So we have a square number. Okay. What was it called again? If it's just, it's also called a
Base?
no.
A square number.
No.
A contrast.
Constant.
A constant. I got that first.
A
Constant term.
Oh.
I said it first.
It was written on that. A constant. So the constant term, the term that is a constant. Do you all understand why it's a constant?
Yeah,
Because it has no
no X.
x, no variable. Yeah, it doesn't change. It's always plus 64. Okay. Now, so that's useful for when we want to go back the other way. All right. As I said, from going from there to there, you're already factorising, which we haven't even started yet. So hopefully you don't forget that. The next thing, though, again, we're going to find useful when we start factorising is something called the difference of two squares. Okay. Now, to be honest, the perfect squares one, you don't kind of need to know it's a perfect square. You can kind of use basic factorisation knowledge if you want to go there. But the difference of two squares is a bit different. Okay? If you don't remember the difference of two squares, there are things that are going to come up that you'll find really, really difficult to do. Okay? So, the difference of two squares, I'm going to give you it in factorised form first, like we've been doing. We've been expanding the brackets. So an example of the difference of two squares would be something like a plus 3 times, or multiplied by a minus 3. Okay? So a perfect square, they were both the same. But in the difference of two squares, they're a positive and a negative, but the same number. So I cannot write, tell me why I can't write x plus 3 squared. Why can't I do that? Okay, so if I said it was squared, that would be both of them being positive, yeah? Well, if I did a minus 3 squared, that would be both of them being negative. So neither of these apply. Okay, this is not, oh sorry, that should be a square. You cannot represent this using these forms, right? They're not the same. So we don't have that shorter way of writing it like we do the perfect square. What is different though is what happens after you've expanded the brackets. So I'm just going to ask you to do that for yourself now. You can remember doing your FOIL stuff or adding, subtracting. I want you to expand that and tell me what you notice. Just do it first. Right, let's have a quick look at it then. Did you do your FOIL?
Yeah.
Firsts are
A squared.
a squared. Then we did outsides. So firsts, outsides are negative 3a. Insides are positive 3a. Lasts is negative 9. And when I collect those together, negative 3a, positive 3a becomes 0. So I end up with a squared minus 9. So how is that a different one? Yeah, so that central term, that a term, there isn't. They've cancelled each other out. The positive 3, the negative 3, they cancel each other out. So how many terms in this one? 2. How many terms in the other ones that we've done? 3. Any ideas why it's called the difference of two squares? Think about the words. What does the difference, how do you find the difference of things? Subtract. Okay. And what are squares? Square, it could be a square, but in this sense we've got square numbers. Do we have the difference, so the subtraction of two square numbers? No? Yes? No? What? Yeah? What do you reckon? Is a squared going to be a square number?
Yeah.
Yeah.
Because it's multiplied by itself.
Because whatever you end up doing, you'll end up with a square number. Because if you square something, you get a square number, whatever it is. So a squared is a square number. And then I find the difference between that and what squared? 3 squared, no? 9 is 3 squared. I got it by doing 3 times 3. So I've got a squared minus 3 squared. Okay? So that's good because, again, we're looking for potential shortcuts, which is, well, if I said to you to expand x plus 8 and x minus 8, x squared minus 64. Yeah? If I said to you, expand a plus b times a minus b, making sense? So we don't need to be able to go straight there. We could do FOIL like we did with the first one, but actually if we can see, that's what the difference of two squares looks like. I can write that straight away. Okay? Which, again, becomes more useful when we want to go back in the other direction. So if I said to you, Sarai, if I said we've got x minus 16, x squared minus 16, sorry, and I asked you for what would the two brackets be? Exactly. Got that? Nice and easy. If I said to you, we've got 4x squared minus 9, what do you think the time?
2 plus 3 brackets
Not quite.
Oh, exactly.
You did the hard bit. Exactly. Yeah, because 4x squared, I'm impressed, is 2x squared, and then that's minus 3 squared. Jaden, tricky one. Y plus what? Okay, y plus 5 and y minus 5. I've been nasty to Jaden, but the rest of you are not saying anything. I have been quite nasty. Getting you to, I knew you'd say that, but then I knew no one else would pick you up. Is there something wrong?
It's plus. Oh.
Expand it for me. Expand what Jaden told me it was. She did exactly what I expected her to do. And you all responded exactly like I expected you to respond. Not to talk. But what I want you to do is, let's verify whether she's right or wrong. And how do we do that? We have to expand the brackets. Let's check that what I asked her to do and she did works. So, how do we verify it? We expand it, see whether we would get there. So what do we get? Y squared minus 5y plus 5y minus 25, which ends up being y squared minus 25. So was Jaden correct? No. Now, every now and again, a student will get this straight away. They'll go, Cyrus Potts, you're tricking me. Because I remember at the very beginning, you told us what's the title? Okay, what was the emphasis? What word did I emphasize a lot? The difference. Difference, I asked you, means subtraction. What did I give Jaden? Addition. It's not the addition. Wait, no one else spotted it, Jaden. And just take it in that I expected exactly what you did, right? That is the addition of two squares, and two brackets don't ever multiply to make that. Okay? You won't get this one, all right? You won't get this one. From multiplying two brackets in that way, okay? Because of the addition here. But it's a common one to throw into a test to see if you remember that it must be, what's it called again? The difference of two squares, not the sum of two squares. Or, pardon? Well, I would have, right, so good question. What I've just asked you guys to do to give these brackets I've said is the opposite of expanding brackets, which I've called what? Yes, factorising, well done. So this is the factorised form. So when we've done properly factorisation, right, I would then say factorise these where possible. Okay? And if I gave you this one, you would write not possible. Okay? It's not possible. Yeah, this does not go to that. Okay? This one, right, does not do that. This one, though, does, because it is the difference. Okay? That's a difference. That's a square, and this is 5 squared. So it sticks with that rule of the difference of two squares. This one is addition. It is 2 squares. This is still 5 squared, and this is y squared. But it's the addition bit that is the problem. Okay? So it wouldn't work. So if I said to you, factorise where possible, for that particular one, if I gave it to you in a test, you'd have to write, does not factorise. You know, something along those lines. Perfectly good answer. If I just wrote, factorise all these, and then I gave you that, right, that I would have written a bad question. Because you would be thinking, well, I can factorise it, and you'd try and you maybe, and you would then rightly afterwards, when I mark it, you'd go, but you said we could factorise and we couldn't, and now you're so you need to scratch that from our test, and then you need to give us an extra 50% because we wasted 3 hours trying to do it.
So you're not going to do that.
No, I'll be very careful not to write. But yeah, we've got to be careful when we write questions. If I say to you, factorise all these or expand these, that you can actually do it. If I give you a question where you can't do what I've asked you to do, then that's a bad question in my opinion. So anyway, just to summarise, we now have the difference of two squares, so expanding them, so you know what it looks like. A plus b, a minus b, and it will end up being something squared minus something else squared. We've also got the perfect squares stuff, which we looked at, which is if I've got something plus something squared, we end up with c squared plus 2 lots of c times d plus d squared. Remember we did it before as well with a's and b's as well. A squared plus 2ab plus b squared. Okay. Also works with negatives because remember it's you treat it like you add a negative, so the a would be f and b would be f. So you've got the two different things there. So in the exercise in the book, you've now got perfect square stuff that you've already been doing some of yesterday. You can move on to the stuff at the bottom of the page and over the page on the difference of two squares and have a bit of practice with those. Okay? Add any notes that you feel you need to from the paper. Okay? Let me know if you have any questions.